the question 6. Let us answer question 6. So this one I've modified it because some of the questions I've just fused it in so that at least we can have the wider part where it caters some angles of the topic. So what is the question? Butene, that is C4H, is a compound belonging or that belongs to alkenes. So here specifically they've told you that butene is a compound that belongs to what? Alkenes. State the general formula of alkene. So this one is just a repetition of what we've answered. The general is CnH2n. That is the general formula for alkenes. Draw the displayed structure or draw the formula or display the formula of the second member of the series. Draw the display structure or the second member of the series. Now, if we are to look at this, you need to be very careful. The member of the first member of the series has 2 carbons, which means the second has how many carbons? 3. The third one has how many? 4 carbons. There's no one that has 1 carbon. So that is very important to take note. Some of you might start from 1, or you might give ethene as the second one. So the second member has 3 carbons. So in short, they are asking us to draw the structure of propene, of which we've done already at some point, but we're just going to do that. So draw the displayed structure. So when they say draw the displayed formula of this, I mean the compound that has, or the second one in the series, you surely have to show the bonds. So in this case, you are going to say, or you are going to draw propene, I mean. It appears like this. So this one, there's hydrogen there, hydrogen there, hydrogen, here is only 1 hydrogen, here there are 2 hydrogens, here there are 2 hydrogens. I guess you've understood what I said, is that the second one, in this one, it is the third one. If we are to look at number of carbons, or it has 3 carbons, so it is at position 3 in terms of carbon. So you look at the first one to be ethene, the second one to be propene, the third one to be butene, fourth one to be pentene. So that is how you look at it. Then now the C question, butene is prepared by cracking petroleum oil. Name the other method by which it may be prepared. So another way, in short, how propenes, or how, I mean not propene, how alkenes are prepared aside from cracking. Yes, cracking is one way alkenes are prepared, or you can obtain alkenes. But what is the other way aside from cracking? So another way that you can look at is dehydration of alcohol. So here I'll put dehydration of alcohol. So when alcohol are dehydrated, that is water is removed, they return to, they become alkene. As you know, hydration reaction results into alcohol. That is addition of water to alkenes resulting to alcohol. So when you remove water, you are going back to the what? Alkene. So in other words here, since butene is an alkene, and therefore we can safely say is dehydration reaction. Okay? Then what about the D question? But1-ene can be polymerized. But1-ene can be polymerized. Now, this one for you to know, this one means that the double bond is at carbon 1. So if you are to draw butene, but1-ene is like this. So 4 carbons, it's going to appear like this. Okay, so around hydrogens, hydrogen, hydrogen. Here, hydrogen only 1. Here, 2 hydrogens. So it's going to appear like this one. The double bond is at carbon 1. So it is like this. Okay, let me just remove this part so that we decongest this area. Okay, so they are saying can be polymerized. And of course, you know that they undergo additional polymerization. So name the type of polymerization it undergoes. So I've just given already. That is the additional what? Polymerization. Polymerization. Where the repeating unit, in this case, they keep on adding. Okay? So it's additional polymerization. Then draw and give the name of the polymer formed from but1-ene. Show at least 3 repeating units. You see? In this one, they've told you that show at least 3 repeating units. So which means you are going to draw at least the 3 repeating units of butene. Okay. So now, how are we going to draw it? So you know that butene, the formula is drawn like this: C double bond, like this. Okay. Let me just put it here like this, as you can see, like this. So this is the carbon. This one only had 1 hydrogen. So please, you need to make sure that a carbon is attached to 4 bonds. So this carbon, double bond, plus 1 plus 2, 4. This one, 1, 2, 3, 4. 1, 2. So all the carbons should be attached, not more than 2. So not more than 4, I mean. So if you have to put another bond here, that is not true. Okay. So now, for you to form the polymer, I said you need to expose the double bond, where you rewrite this one. Okay. You realign this one as a group here. Okay. So this whole part, you are going to write it down here. And of course, it's going to be up, down. Okay. You write them up, down in relation to the double bond. So this butene, I'm going to rewrite it like this. Okay. It's going to be written like this before it forms even the polymer. So like this, double bond. Then down here, you remember the other part. Okay. The other part of butene, it was like this. It was like this. Okay. It had how many? It had 2 carbons. How many hydrogens? 5. This part is the one that I'm interested in. Okay. So it had how many carbons? 2. How many hydrogens? 5. Then up here. Then here. Then here. Okay. That is but1ene, the way you write it. Okay. But this one can also be written in other form, where you put, let's say, the double bond, this branch here, another one. Okay, I'll show you that at some point. Let us focus on but1ene. So you're saying at least 3. So you're going to add another one. Okay, another one drawn like this, 2. That is 5. Up hydrogen, down hydrogen. Another one. Since it's an additional polymer, so up hydrogen, down hydrogen, then here double bond, down the part, this part, which is C2H, 5, then up here, hydrogen. Now, what is it going to form here? It's going to form the compound that has how many? 3 of these. So now, in total, the chain, these they break, and of course, they are going to leave the attachment in these sides. So the total of carbon in the long chain will be how many? 6. So you're going to have 1, 2, 3, 4, 5, 5, 6. Then afterward, at the end, you leave the room for attachment of some more. Okay. Then here it's going to be hydrogen. Look at this. We just pick here hydrogen. Then here the second carbon is going to be hydrogen, but down it will be C2H5. Then here hydrogen, here hydrogen, but here C2H5, here hydrogen, here C2H5. On top here hydrogen, hydrogen, hydrogen. So right here is the polymer of the but1ene that contain or showing 3 repeating units. Okay, so what are the repeating units if we are to cut this one? So please, sometimes you're going to find the one that is already given. So you just have to cut them in 2 repeating units for you to determine the monomers. So if you are to cut it, this is the first part. If we are to cut it here, this is the second part. If we are to, okay, this is the third part. So this is the polymer showing 3 butenes. Okay. Now, what is the name of this polymer? It's called polybutene. Okay, it's called polybutene. That is the name. Okay. As the question, is there a question that is asking us about the name? So draw and give the name of the polymer formed from the but1ene. Show at least the 3 repeating units. So we've shown 3. So now this code, so we've drawn, so what we are interested in is drawing this structure. And of course, we've shown the name is polybutene. So the name is polybutene, and this is the structure that we are interested in. Okay, so take note of that. So the name and the structure. Okay. Then the question E, that is E1, butene react with steam in the presence of a catalyst to form a colorless compound. Name the compound what? Formed. So when butene react with steam, steam is water, okay? So when alkenes in general, when they react with water, what is formed is alcohol. So here, naming the compound that is formed, or the colorless compound that is formed, is what? Alcohol. And what is the name that is formed from butene? Is called butanol. Okay? So butanol is the compound that is formed. Compound formed is called what? Butanol. Write the balanced chemical equation for a reaction between ethanoic acid and the compound named above. So now we are writing the balanced chemical equation for the reaction of ethanoic acid and the product formed. So the product formed is butanol. So simply write the balanced chemical equation of butanol and ethanoic acid. Now, one thing to know is that when an acid reacts with an alcohol, it forms an ester. So let us write the balanced chemical equation. So ethanoic acid is written as butanol is written as NC4. Butanol. So butanol is written as C4H9O, okay, OH. Then plus ethanoic acid is written as C3, okay, COOH. Then now what is going to form? What is going to form is C4H9COOCH3 plus water. So when an acid reacts with, this is liquid, this is aqueous, this is aqueous, and of course this is what? Aqueous. Okay? So when an alcohol reacts with an acid, what is formed here is an ester plus water only. These are the products that are formed. So this is the butanol, and this is what? Ethanol. Okay? Ethanoic acid, acid. So now, what is formed is the product called, what do you call the product? Butanol, butyl ethanoate. So butyl ethanoate is the product formed. This is the product. We are going to look at esters at some point as we go on in the question. But at the moment, this is what we can write. Now, is the equation balanced? So here, there's a condition that we can put that concentrated. The condition is concentrated sulfuric acid. That is the condition. Okay? So this is the reaction that occurs. So if you are given the question to write the reaction, right here is the reaction. The colorless liquid produced here is butanol. And now the equation, when the colorless product, or the product that is produced above, react with ethanoic acid, it produces butyl ethanoate, that is an ester and water only, and this is the reaction. So counter check if all the atoms are balanced.